Let's kick it.
Good morning, good afternoon, whatever the case may be.
All right, stop. Collaborate and listen.
That's right, we are going to stop, collaborate, and listen about the awesome, the best, by far of all the disciplines, topic of mathematics. Let's get to it, shall we? Today, we are talking compound interest. So, what is compound interest? Well, if you put money in a bank, you can earn some interest, or in a CD or some other sort of investment, you expect to earn a certain percentage. If you, I don't know, you charge something on a credit card, you are going to be charged interest if you don't pay your account in full by the end of the month or whatever the billing period is. So the amount that you invest is referred to as the principal, and then how often interest is calculated is related to the word compounding. Um, uh, let's see, what do they say here? After a period of time, the interest is automatically added to your account. So you compound the interest when the next time you calculate the interest, you include the interest previously earned. Let's take a look at an example. Let's say we invest $1,000 paid at 6% per annum. A is annum, Latin for year. And it is compounded. So at the end of the first year, you're going to earn 6% of 1,000, which is $60. So now you have $1,060 in your account. So the next time the interest is calculated, it's based on 1,060, not on the original investment of 1,000. That is different from simple interest. This is compound interest, where you earn interest on the interest already earned. So I think that's fairly certain. Important thing here is the formula that occurs. If you can read through this and see that we are going to end up with, in this particular situation, a formula we can use to calculate the total amount or the future value of the account, 1,000 times 1.06 to the n, where n is the number of years that you will have your investment. So based on this, we get this wonderful formula. F sub v, future value, is equal to P sub v, the present value or amount initially invested, times 1 plus I is the annual interest rate, and n is the number of years of investment. Pretty straightforward. So, question here is, what will $5,000 invested at 8% per annum compound interest amount to after 2 years? So F sub v, equals P sub v times 1 plus I to the n. And we are looking for future value. So what is it going to amount to after 2 years? So this would be, the present value is 5,000 times 1 plus the interest rate is 8%, so that's 0.08 to the nth power, so that's squared. So that would be 5,000 times 1.08 squared. I'm not going to show you that on the calculator. I know you know how to do that. So the final answer would be $5,832. And of course, that's part A. How much interest earned? This is so easy. 5,832 minus 5,000, booyah, equals $832. All right, easy peasy. Finding the principal, well, it might be that you have a goal. Like here, they want to earn $10,000 in 4 years' time, and if I'm able to invest 8.5% per annum compounded annually, how much should I invest now to achieve a maturing value of $10,000 in 4 years' time? Okay, so we need, let's see, I'll write out the formula. Future value equals present value times 1 plus I to the n. So our future value is 10,000. Okay, and we're looking for P sub v. 8.5 is 0.085, so that's going to be 1.085. And they need this to happen in 4 years. So to solve for PV, I'm just going to divide both sides by 1.085 to the fourth power. Kapow, search and destroy. I guess I should do that there. And so the amount I should invest is equal to 10,000 divided by 1.05 to the fourth. Rounded to the nearest hundredth, that turns out to be $7,215.74, and that is equal to the amount that should be invested to reach this particular goal. Okay, and then it could be that you have to find the interest. Okay, if I bought a bottle of wine for $550 and 5 years later it was valued at $1,550, at what annual rate has my investment increased? So again, we're just using our basic formula. FV equals PV times 1 plus I to the n. Okay, and so what do we have? 1550 is the future value. The initial investment was $550, so that's going to be times 1 plus I, and number of years is 5 to the fifth. Okay, so then we'll have 1550 over 550 equals 1 plus I to the fifth. And so then I would take the fifth root of that, 1550 over 550, and that would equal 1 plus I, fifth root of both sides, and I wrote a t, I don't know why. So then the fifth root of 1550 over 550 minus 1 is going to be equal to I. So let's go ahead and do that on the calculator. Yeah, I have it right here. So that is going to be the fifth root, which is right here above the caret. So control this, fifth root, and I tab into there. I love to use this little fraction feature on the TI Nspire. 1550 divided by 550. And get out of the square root, and then we have to subtract 1, or the fifth root I should say, and there she blows, so that's going to be 0.23025. Why don't I just copy that so we can look at it instead of me memorizing it and not remembering. So we'll put that over here. Okay, so then so that means that I equals 0.23025, blah, blah, blah. But they say round it, give your answer correct to 2 decimal places. We express rates as percents, so the interest rate is going to be equal to 23.03%, rounded to the nearest 2 decimal places. Okay. I hope you enjoyed that. Let's check back with our good friend Vaneller, see how he's doing for our sign-off. Never gets old, does it? We got to crank that up. All right, hope you enjoyed it. I can now announce that I am